All right, welcome back. We are game 3001 in the summer 2021 semester at George Brown, and it's week 6, part 3 of our broadcast. And we're into lab 6. We're running a little bit behind today, and that's pretty cool because I took a little bit longer with the other group just to make sure everything was working fine. Let's get moving on this and talk about our lab goal for today. So again, a couple things. I want to be able to add the heuristic function, adjust the heuristic function to use the terms that we talked about in class. And what I also want to do is create the shortest path method, display the method on the console, and then finally do some kind of spawn object that can randomly spawn objects anywhere on the screen. Okay, so that's what I want to do first. All right, let's get to it. As a stretch goal, I'd like to generate random obstacles and test path finding. We'll see if that works. Okay, if we can get to that. So first things first, with what I want to do, I want to go to the starter. So the starter is simply just last week's lesson. So please download the starter as I'm doing the same thing. So first things first. By the way, if you have any questions, please, guys, slow me down as I want to make sure that things are good. All right, so I've gone ahead and done what you've probably done, right? Which is downloaded this, and off screen, I've got this right here, which is Lab 5 Master, and I've made 6A for the previous group. Let's do your group. So I'm going to go here to 7-zip and extract to the master, and then just do Lab 6B, which is the thing that I'm going to do with you guys now. Okay, let's double click here, and actually let's get rid of this other one first because we don't need it, and then double click this and run it. And I'll wait till things start off, but I want to go to Solution Explorer first. And under Solution Explorer, when it's done doing its little dance with ReSharper, I want to change a couple things. So in the docs area, just like we normally do, in the README function, or in the README file, I want to change to Lab 6. Let's do that together. And I want to go into under scenes, under play scene.cpp. I want to go into that IMGUI function. Let's get rid of this. Let's clean this up too, right? Because this is an issue, right? By the way, if you ever get this kind of thing happening, this is rare, but it can totally happen. Why? Because we're not in x64, we're in x86, and that's why telling me something's wrong. When I shift back to x86, it'll go away. This is a good example of like, hey, I got all these errors. What do I do to fix it? Well, you're in x64, not x86, and that's why it's not finding it. Okay? So let's do the next one. So now that I've got this, right? Let's do the next part, which is I want to modify the IMGUI function down here. So instead of saying Lab 5, it'll say Lab 6. Okay, and let's put this up on GitHub. So again, I want to right-click on the solution. I want to go to Create Git Repository, and then I want to target George Brown, and then Game 3001 in the summer 2021 semester, and then it is Lab 6B, which is you guys, right? I want to make it public. That's important. And we're going to create and push. Okay? So step 1. Once I have this, let us talk about that heuristic function, which I want to modify. That's this part here, adjust the heuristic function. The heuristic function actually exists inside of the compute function. I did it down here in the compute tile costs. Right now, what I've allowed you guys to do is switch between Manhattan and Euclidean, and that doesn't make sense. What I really want to do is think about this pseudocode that we were given here, right? So on page 10 of the PowerPoint from today, it says, I want to take the F and add G and H to it, where G is the tile cost and H is the heuristic, F is the pathfinding function. So this is nice, but it's not what I want. Instead, what I'm looking for is, it's going to be, I want to find the float F, which is going to be 0.0, and float G, which is 0.0, and float H, which is 0.0. Okay, so I want to kind of get these terms going. I want to separate these terms. Do I need to do it? I mean, I don't have to do it this way. I'm doing it for clarity. That's all I'm doing it for. All right, so that's the first thing. So first things first, what we want to do is you guys can hear me okay, by the way? I'm hoping. Welcome everyone, by the way. I'm kind of rushing to start. I want to not do this, right? I want to make this the distance function, which is F, right? This is the part of the pathfinding for each tile. Okay. So what I want to do here is exactly what we talked about. I want to calculate the distance function. I want to have a heuristic calculation. And usually what I want to use, we know that Manhattan distance is what I want to use, right? And then finally, I want to have the pathfinding function calculated as well. So those are the things that I want, okay? I'm just doing it in comments so you know. It's like pseudocode. So the first thing is, let's talk about the G, because that's the distance function. Now you don't have to use a distance function, but I find it's useful. So what I want to do with this is just do this part. So boom, and put this in here. So that's the distance function. Okay, distance between each item as the target and each tile as the crow flies. All right, that is the distance. I'm going to use that Euclidean to help me. Okay, and then for the heuristic calculation, I still want this, right? But I don't want distance to be this. I want this to be H. So the heuristic function is really the Manhattan distance calculation. Now that I have these two pieces, I don't need any of this. Okay. For every tile in the grid, calculate the distance, calculate the heuristic, and then finally do the pathfinding function, which is F is equal to G plus H, and then set the tile cost to F, which is the heuristic function. Let's try this out and see what happens when I do that. One day when it starts, we should see the difference. And I'll put this up on GitHub in a second. So I want to turn on the grid, and now you notice that the heuristic function is different than what I had before. Notice that before, when I was using Manhattan distance, I was getting ties on everything. Everything was the exact same, right? But now, when I have a distance function, right, which is the G, right, then notice that I have a clear winner right here until I get to the diagonal. When I come to the diagonal, which is right here, notice that the diagonal goes from here all the way here. You can see that I have 25.6 here and 25.6 there. Those are the exact same, right? So now it's going to go by winding order. So it's going to start off with top, right, bottom, left. Top is high, right is low. It's the same as bottom. So we're going to take right, and we're going to keep on doing this kind of step as we go forward, like this, from here on in, until we get to here. And that's going to be the pattern that it's going to take with Manhattan distance and the Euclidean distance as the distance function. You don't have to use the Euclidean distance. You can use something else. The distance function could be your own function. It could be a calculation based on the way the tiles look. If you remember, you're making a pretty map, right? The distance function can be based on a walkable area like a road, right? As opposed to me making a distance function like this, okay? So here I'm just saying that the distance function is going to be calculated by using Manhattan distance, or sorry, the Euclidean distance, okay? So I can say that. I'm only doing it once, so it's not bad. It's not a bad, cost for me doing it one time for each tile, right? If I recalculate, if I compute the tile cost again, then it would do it over and over again. So let's put this up on GitHub because that's the first thing we've changed. So again, I'm going to go to Team Explorer and I'm going to go to Git Changes and I'm going to say adjusted compute tile costs function, which is what I did, right? Commit all, home, sync, and push. Okay, so that's the first change that I made. Yeah, and we've taken care of this piece, the first piece. Now the bulk of the work, which is this. How do I do find shortest path? And what do I recommend for this one? Well, this is where it gets a little bit hairy, okay? And I'm only going to do one path. I'm not going to find all shortest paths or all paths. That's on you to find, okay, for your assignment. I'm going to find the first path. So it's not going to be a complete version, like I said before, okay? Back to this. Let's do it inside of the placing.h. I'm going to comment out this find shortest path function, and let's implement it. Okay, so when I do the find shortest path, what I want is to have those data structures in play. The three data structures I'm going to be using are these ones. Okay, so let's just uncomment those two. I also not going to do path of visibility. This is for you to think about. Should you do path of visibility to improve or optimize? That's on you. And if you're interested in AI, you may want to consider that. Okay. But for us, all we need is these three. And I'm not really going to use my open list fully, as you'll see in a second. Okay, so how does this work, this find shortest path thing? Well, first, I want to say that let's check to see if my path list, right, is empty. If it's already empty, then do this thing. If it's not empty, somehow don't do it. First step that I want to do is I want to add the start position to the open list, right? That's what I want to do. That's as per the instructions here, okay? So what I mean by that is, let's go to the open list for that. So if you follow the heuristic, it tells you that. It says, hey, let's initialize the open list and then initialize the closed list and then add the start method, the starting node to the open list, which is what we're doing, okay? And that's what we're going to do here. So the first thing is let's do that. So how I would do that is auto, let's call this start tile, and that's going to be equal to m underscore get tile, and it's going to be m underscore p starship. That's the start tile. That's where it's going to be right now. And then get grid position. So that's going to be the position of the starship. I'm also going to say that start tile, right? Let us set tile status, and we're going to set the tile status to open. So we're going to change it from start to open. This is an important consideration, right? And then I want to say that the open list, I'm going to push back the tile, start tile, to the open list, okay? ReSharp or C++ doesn't like my naming convention. It suggests that I use start tile, and I'm perfectly fine with that. That's kind of a change from this morning's version, okay? So that's the first thing. The next thing that I want to do is I want to also say that let's make a Boolean that's called goal found. And we'll say goal found starts off as false. We don't have the goal found yet. Now, this is all initialization step. So that step 1 is really initialization. And we add the start position to the open list. So guess what we do here? Step 2 is I want to loop, right? I want to loop until the open list is empty or the goal is found, right? Which is exactly from this thing here. While the open list is not empty, as an example, and if the goal is not found, then keep looping. So let's do that. So I'm going to say while not m_p open list, right, is empty and not goal found, right, then loop, okay? And I want to start off with a minimum number. It's like finding the minimum, or a min function, custom min function, which I'm going to say, let's start off as infinity. Whenever we have a custom min function, we always start it off as infinity. It's like the biggest number wherever we ever can find. This is kind of classic. And then I want to make a min tile pointer, right, which is a temp tile pointer, right? And we want to initialize this. It's initialized as not a null pointer, initialized as null pointer by default. I want to have the min tile index set to 0. Okay, now it's not going to like this. And notice it says that my suggestion is that it wants to do min tile index to 0. I'm fine with that. I'm going to go with the suggestion for this one. I'm also set my count. Okay, and this count, what it's going to calculate is I'm going to go to the neighbor index is what this is. So count is really just a short form for the neighbor index. Okay, and this is kind of count the neighbor index. Okay. So this is kind of like we set up the min tile, and this is more initialization inside the loop. Every time we loop, we start off like this. We start the count at 0 again. The neighbor index we're looking at, we make a a temporary tile pointer to look at the minimum tile that we're going to return. Okay. And then what we want to do is, there's different ways of doing this, but I found that the easiest way was to make a standard vector, right, of tile pointers that I called neighbor list. Yeah, there's my neighbor list. And then I'm going to do a for each, or actually a for I, and I'm going to say that we're going to call this index for index, as an example, to the number of neighbor tiles. Wow, that's terrible. I hate when that happens. My thing is weird. Number of neighbor tiles. Just got to select it. That's all. Then what I want to say is, as long as the m_p open list, the first member of the open list, which is the start tile, I want to get the neighbor tile, and I want to static cast. I want to static cast the neighbor tile as a neighbor tile. So you hear me what I'm saying. And I want to static cast the index as a neighbor tile. So as long as the neighbor tile, right, as an example, is not equal to null pointer, because we don't want to, that could happen. And remember where it can happen up here, right, in the corner. So where I'm searching the neighbor tile here, 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 and here, and those neighbor tiles could be null pointer here and null pointer here, okay? So that's where it can happen. If it's not that, then what I want to do is I want to say that, hey, neighbor list, let's push back that tile, this one. And I could do it this way, right? I could do this. So this is the neighbor tile, right? Whatever the neighbor tile is, right? I could also make it so that that neighbor tile is a temporary tile, and I don't have to do it twice because I'm polling this twice. That's what I'm doing, right? So I could do, wow, that was weird. I could do this, right? And so what I'm saying is that I want to add to the neighbor list for each tile of that particular object. So example, if I'm looking here at the start, I'm going to push this one, this one, this one, and this one onto the neighbor list, references to each of these tiles. But if I was here, right, then I would only push back this one and this one, but nothing else. I wouldn't pet if this was the start. So there's two possible starts. Let's just go here. So if I'm here, then I'm only going to push back these two tiles. That's a case. Same thing down here. I'm only going to push the top and the right, and so on. Okay, and we've accommodated for this because this tile, the reference for the top and the left are null pointer. Okay, we don't want to mess with these ones, right? So we want to not push them onto the neighbor tiles we want to check. We don't want to check the ones that don't exist, is what I'm saying. Okay, so this little function here loops through each of the neighbor tiles as an example for each tile, and only selects the tiles that are non-null pointer, non-null. Okay, and adds them to the neighbor list. Okay. Now, for each neighbor tile pointer in the neighbor list, right? What I want to do is I want to find the minimum tile cost, or find the tile with the minimum tile cost. Find the tile with the minimum tile cost and return it. Okay, that's what I want. Okay, so that speaks to what I need to do. I'm going to do a for each, and a for each is a range for loop between my neighbor and the neighbor list. So here's my neighbor list. Let's make this neighbor. So for each neighbor in the neighbor list, that's how you read this, right? If the neighbor, just by chance, because this is going to happen, if the neighbor is not null pointer, most likely it's not going to be because we're not going to have anything in there, but this is just an additional check, right? Again, more of a hack than anything else. Then if the neighbor, right, we are exploring is not the goal, right? So we can say that if neighbor get tile status, right, not equal to goal, if it's not the goal, then we want to do some work. Else, if it is the goal, then exit, right? Make it the minimum goal, minimum tile, and exit. So that would be else. What we want to do is we want to say that the min tile then, the min tile is equal to the neighbor, whatever that neighbor is, right? And the path list, I want to push back the min tile. Okay. I can also say that the goal found is true, and I want to break out of this loop, which actually will take me to break out of this loop, which actually will finish my shortest path. Okay, that's what it'll do. So this thing here, this for each loop, what it's going to do is going to go through, run through each of the tiles, the neighbors in the neighbor list for each of the tiles that I'm checking, and it's going to say that, well, did I find the goal? No? Okay, then do something. If I found the goal, then mark it as the minimum tile and then exit. So then what I'd want to do is, if I didn't find the goal, then if the neighbor get tile cost is less than min, and the first one will always be true, right? Because remember, if I start off as, let's undo this change here, and let's look at the open list, the closed list, the path list. as an example. Min originally is equal to infinity, but then when I go to the top is, and let's suppose this is the goal and this is the start. Top, obviously that's not shortest, right? Right or bottom might be the same, let's suppose, but it's going to take the rightmost tile, which means minimum is always going to start off as whatever the minimum tile is, right? So it's going to just change. Whatever the first one is, doesn't matter which one. Actually, even if you just check this one, at the beginning, minimum is going to be, because it's going to start with the top tile, potentially, it's going to be T, right? And then after it checks the second time, because R might be closer than T in this scenario, then the minimum will be the T, the R tile, and so on, okay? So it'll point to the value. So min, neighbor tile get cost. If neighbor tile get cost is less than min, then you want to say that min, right, which is the value, is the neighbor get tile cost. So that is the minimum value. And then the min tile then is going to be equal to the neighbor pointer itself, the tile pointer that we're looking at, right? And then min tile index, which is this one, the index of that is going to be equal to the count, starting off at 0, okay? And what I want to do is count plus plus. So why is that? Because if I count, I want to go from one tile to the other tile until there's no more tiles in the neighbor. So 0, 1, 2, 3 in the list, right? And again, all I care about is the minimum tile costs, right? So that loops through each neighbor tile and returns to me the minimum tile, whatever that is, okay? And most likely, it's not going to be the gold tile starting off. It's just going to give me the minimum tile, okay? Right now, we're not using the minimum tile index, not yet. Next, so once we leave this function, then what we want to do is we want to remove the reference of the current tile from the open list. That's what we want to do. Now, this is where you're going to say, well, why do we need the open list yet? And the answer is you don't in this example. Because remember, I'm not giving you the full thing. I'm giving you part of it because you need to figure out the rest. So I'm going to say that let's look at the open list 0. And I want to make that the part of the path list. I'm going to say path list is actually going to keep track of all the vertices or all the vectors of the path that it finds from the start to the goal. Okay. And then we're going to say m_p open list, and I want to pop back that single tile, which basically empties the open list. That's what it does. I could have also done clear, but that's what that does. Then I want to add the min tile, right, to the open list, because that's the new tile I'm going to run with. You can also see this as a recursive function, right, where I come back and then I do this somewhere else, where I say that the open list, then I'm going to push back the min tile. Okay? And then what I want is my min tile, set the tile status to open, just like we did earlier. And then the neighbor list, I want to erase from the neighbor list begin, I'm going to use that iterator, plus, and this is the key, min tile index, wherever that min tile index is. So I'm only going to erase, the tile that exists, as an example, the one that I found in the open list, right? In the neighbor list, sorry. And then whatever's left in the neighbor list, I want to add all those to the closed list. So push all remaining tiles or neighbors, let's say neighbors, in the neighbor list to the closed list. Why? I'm not going to go there anymore. Those ones I've already explored. So again, I'm going to do a for each. And I'm going to say for every neighbor that's left in the neighbor list. So first I prune the neighbor list by removing the neighbor that has the minimum tile, the minimum cost, if you will, right? And then after I've removed it from the neighbor list, I want to loop through the neighbor list. And if the tile status for the neighbor is not or is equal to unvisited, so if it's already closed, don't add it in. I'm not going to add it in twice. I only want to add it in once, because that can happen. Where the neighbor, I want to set the tile status to closed. And M_P close list, I'm going to say that I'm going to push back the neighbor. So what this does is it does a bunch of things here, right? One thing is, and we're gonna let's review this one more time. It's a big, kind of a big, hefty function, and we can break it down into smaller little functions, right? One of the things we can look at is like, what is this doing? What is this thing here doing? Well, what this is doing is it's like creating the neighbor list. So create a temporary neighbor list. Okay, that's what it does. So this is going to create a temporary neighbor list from the current tile that we're looking at, right? Whatever the current tile that I'm looking at is. Okay, I want to make a little neighbor list, all the neighbors in the list. So what I'm going to do here is for this tile, I'm going to, if this is the neighbor list, I add the top tile, the right tile, bottom tile, and the left tile, right? But if I was over here, right, as an example, I would only add the top tile and the bottom tile, sorry, the right tile and the bottom tile. Top tile and the left tile wouldn't exist, right? Because I'm on the corners, right? And this would be actually here, right? So that's the only thing in the list. That's the only thing left. Then I want to pick the minimum one from the list. So which one of these would be the minimum? Well, maybe it would be this one, okay? Because we're right winding. So I would take this one, and this one would go on the open list as an example, and then this one would go on the closed list. So I wouldn't do that anymore. And then the neighbor list, I'd wipe it out. And then I would go back and do it again from the new tile, which is the minimum tile. So for example, if I found that the right tile is the minimum tile, then I would start off with that one. Okay, now here I am. What's the neighbor list of this one if I was here? Well, I got the right tile and the bottom tile. And then I would put this down in here and do the whole loop again. Okay, so that's how it works. So this tile, this bunch of code here, what it does is it returns for each neighbor tile. So loop through each of the neighbor tiles and find the minimum tile cost and return it. So this is the first part. And then what we want to do is prune back any of the neighbors that we found and put them in their respective lists. Put the one that we found in the open list or the path list. Right? That's what we want. So one could argue that since we're not using the open list really, we can get rid of it, right? We can just use the path lists. Path list could be the open list, if you will. But I want you to think about it in your heads, guys, that the open list could also include inflections, places that you're going to have ties and all that stuff, because you want to find all the paths, not just one path. Here, what I'm doing with you guys is finding a single path to the target, okay? All right, so now that I've got this thing made, this find shortest path function, then we need to test it, okay? And the way we're going to test it is we're going to calculate it every time we start. So we're going to go into top here in our start function, and we're going to do this find shortest path, before, we think about this. So we compute the tile costs, right? And then after we compute the tile costs, well, we want to find the shortest path. Right? So we'll just do that right here. So we'll say M_find shortest path at the end. What's the shortest path after we computed the tile costs? And show it to me, because when I do this, I'll actually show you the shortest path. Let's try it. So boom. And it'll do it in a second. And if I toggle grid, then we can see that clearly there's the shortest path. Okay. However, if I move this around, it doesn't recalculate. Okay. In fact, it just wipes it out. Right. So this doesn't really work the way I want it to work right now. I'm just showing you that it works for the first time. So this is good. Find shortest path is functioning. Let's put this up on GitHub. So Team Explorer, Git changes, and I'll say created find shortest path function. Okay, so commit all and then push. And that takes care of this part, right? But we didn't do this piece, right? So I want to click on IMGUI, and when I click on the find shortest path button, I want it to do what it's supposed to do. And that's great. But the problem with that is with IMGUI, if I go back to this and I make a button like that, let's make a button. So let me explain this for a second. So here's a reset button. Let's make another button, and we'll make that the find shortest path button. Call this find shortest path. So when I click on this button, it's going to say find shortest path. Then I want to do that calculation, m underscore find shortest path. Yay, right? And I can do that. So instead of doing it every single time, this is kind of the one way I can do it. But it's not really great because, well, once I do it, let's suppose I don't want to do it here, but I want to do it here and find shortest path. Yeah, it did it one time. But now that I move it again and find shortest path, it's already done, right? Remember I did that calculation which just says if the shortest path already exists, don't make another one. So we need to do something here to clear it up. And that's what we need to do next. So in the IMGUI function, we need some kind of method, as an example, to when I find the shortest path, if I'm clicking on find shortest path button, I need to be able to somehow do it again every single time. And I'm talking about this because it's like there's something missing from this find shortest path function, right? So every time I find the shortest path, as an example, I want to loop through, right, as an example, and then, do it again and again and again. Well, maybe for now, I need some kind of a way of resetting. And one thing we can do is we can have a reset method that resets the shortest path. It's almost like reset the grid, which is probably a good thing to be able to do anyway. I should be able to reset the grid anytime I want. Okay, so let's do that next. So in here, I'm going to make a little utility function in order for me to do that called reset grid. Okay, so it'll be under convenience functions, and I'll say reset grid is going to return void. And for now, it might not be the only thing to say. Maybe I'll change it to something else later, but for now, let's just generate the implementation for this. So what do I mean when I want to reset grid? Well, I want to make a for each loop, and I want to loop through each member of the open list. And in the member of the open list, I want to, for every tile in the open list, I want to set the tile status to unvisited. Okay? And I want to do the same thing for the closed list and the path list. So closed list, path list. Okay? Whatever the tile is. And then later on, I want to clear them up. Okay? Okay, so those are the three things I want to do. I want to clear them. So first I make them all unvisited, right? And then I clear them up. So there's nothing in them anymore. They're gone, all right? And then what I want to do is I want to reset the start tile. And I also want to reset the goal tile. So whenever I reset, I want to reset them as well so that wherever the goal tile and the start tile are, I want to set the tile status to start and set the tile status to goal. We have examples of that inside of the function, the IMGUI function, where I have this for the starship. That's the start tile. And I have this for the for the target where I can set the tile to gold. Okay. Again, this is the first kick of the can for my reset grid function. It doesn't reset anything other than it just changes everything to unvisited, right? It doesn't recalculate anything. It just sets everything to unvisited, and I reset the start and the goal tiles again because I need those start and goal tiles to calculate where am I going to start and where am I going to end. Okay. So that's the reset grid function. And what I can do is when I click on the reset button, which is in here, I can call m_reset, right? But I don't just want to do it here, but every time we move the tile. So when I move the tile, if I move the start position or the goal position, I want to reset. So I'm going to say reset, right? And before I do compute tile costs, I want to reset, right? Because that makes sense. So I'm going to reset the grid every single time I move one of these two things. Okay, let's see how that works. So again, I have this thing happening. Now the actual reset button works, right? And let's see if this works. So again, bring this up. I put this grid on and I find shortest path. Yay, and then I move it around. And I find shortest path again. And I move it around. And I find shortest path again. And I move it around. And I find shortest path again. You can see how that worked along the edge. That was our null pointer check, right? And you can see that it works pretty much anywhere now. No matter where I go, I can find the shortest path from one place to the other. Let's print this path out, right? Because that is the next thing we want to do here. Well, first, we've done activate an IM GUI when clicking the find shortest path button. All right, so we did that. Let's put that up on GitHub. So we're going to say git changes, activate find shortest path in IM GUI. Okay, commit all and push. Awesome. So that is that piece. All right. We're able to reset the grid and all that kind of stuff. Next on the docket is I want to create the display list method that displays nodes and path length on the console, right? So that is not that difficult to do. It's really me looping through each of the nodes in the path list and displaying them on the console. Let's do that. And this will help us with moving the ship later. So again, I want to do that in the place scene where I want to display the path list. This is kind of another to do. Let's make sure that we have a implementation for that. Here it is. And what we want to do here is exactly that. We want to do a for each loop, and we want to go to m_p path list. The path list for every node in the path list, for every one of those, I want to print them out. So it's going to look like standard cout. And I want to say that let's start off with a bracket, and we're just going to print out the get the grid position .x. Actually, no. Get grid position .y. Oh, typing is not a thing today. All right, and finally, let's print out the path length. Oops. Okay, so that's the path length. So however big the path list is, that's the path length. Let's see how this works. And the other thing is that we can't really clear the console, but what we could do, and I forgot to do this in the previous class, is maybe do something where instead of a path length, we kind of put in some kind of dashes or something just to separate each attempt, right? Otherwise, again, we can't tell when we start pathfinding and when we end it. Okay, so this is kind of the start. So new path, right? And then we'll say start path and end path. So it's the path length, whatever it's going to be. We can actually surround this. If we want to really make it fancy, we can kind of do one of these, right? And we can even add another \n in there. So just to give us another little bit of separation between one and the other. Okay. Yay. And it's just to make it, nice. Okay, so what does this look like? We'll do the display path list every time we do a find shortest path. So right at the end, before this thing finishes, we'll do m_display path list. Okay, and let's see how that looks. This is for debugging purposes for us. That's why we're making this thing. So run. So again, find shortest path, and you can see that here is the shortest path, path length 23, right? So if I was to move it around, let's move this somewhere else, find shortest path, and then you can see the path length is 17, right? Move this around and move it up and find shortest path. And you see the path length is 10, and you can see how it goes. You can kind of mark down each of the paths and what's the path length. Okay, so again, I'm trying to help you with your assignment, and that's why I'm doing this. Yeah. And it's probably would be a good idea to make these the same length, just so if we're going to do this thing, let's do it right. Okay. Awesome. Okay, so that is path list, and we display everything inside of the console. That's done. And let's put this up on GitHub. So git changes, we're going to say added path list function. And all, and push. Yes, I do. Tam's asking, I thought for A2 you wanted total tile cost, not path length. I want both, kind of. I think the path length, you can do the same kind of calculation where you can go through each of the tiles in the path list and add up the path length in the tile, and then create that. But path list is just this. If I wanted to display the path cost, that's another calculation. So inside here, I can make a cost function, right? A cost variable. That's all you'd have to do to make that happen, Tam. And then you would just add the cost of the path, full cost. So pretty easy. Okay, but again, I mean, you don't have to do it in here. I'm saying this is, you can make another function that calculates the path length and the path cost. I'm just doing it here in the printout because it's just easy. Okay, so great. So we've done this. The next piece is I want to be able to spawn my objects in any location I want. Okay. So this is where I kind of ended last time, and I'm already way ahead of where I was in the first one. Let's do that next. So yeah, this is where we're going to get a little bit more. We're going to do some more work. No problem. I'm not sure if it's going to help you, Tam, if I did it differently than you. I know you finished, but I wanted to, give you another sense of how to do this. And then, we'll see how it goes. We haven't moved the ship along the path yet. That's not something I've done yet either. And I'll talk about how to do that as well. But I want to, talk about this other stuff that I want to do, which is I want to spawn object, which is going to return we'll kind of do over here. We'll say an integer m_spawn object, right? And when I say object, it's like a navigation object. So random location of an object anywhere I want. I want to pass in a reference to the navigation object pointer. We'll just call this object, whatever it's going to be. And in the implementation details, what I want is I want to start with auto offset. We've kind of done this before. And instead of me typing it, I'm just going to grab it because we need the offset because we're going to change the transform. Again, this is something that we've done over and over again, and it's yelling for it to be adjusted somewhere else other than this, okay? Because we're doing it over and over again. And there's many places to do this. I'm just not going to do it. I'm just going to grab this right here, this line, and the offset is just a vector of this. This could even be in the config, kind of file. So in config, go to definition. I could calculate the offset, maybe have a little function that does that, right? That calculates the offset between these two things, right? Over here. I could do that. Not doing it, all right? It's not important right now. I'd rather have code duplication. You go fix it later, right, for now. So that's the first thing. So I'm going to say offset, hey, offset, that's equal to this, right? Really, it'd be like config tile offset is what it would be, right? Where tile offset is the offset. And I can go through and remove all those lines, but there's not that many of them right now. But you can see where there's code duplication and there's a call for that. All right, so that's the first thing. So then I want to make a tile. I'm going to call this random tile. My random tile is going to start off at null pointer. So it's going to be just an empty tile. And what I want is my random tile index, right, is going to start off at 0. Okay. And what I want with this is I want to do a do while. All right. So a do while is kind of rare, but I want to do it at least once. So I'm going to say that while what I really want to do here is search for an empty tile. Let's keep searching for an empty tile until you find at least one, is what I'm saying. And the way to do that is going to do something like until the random tile that I found, if I get the tile status, right, and if the tile status is not equal to unvisited somehow, I want to find a tile that's like completely empty or unvisited. And instead of empty, I want to find an unvisited tile, which is kind of a better way of saying it. So look for an unvisited tile. Did you find one? If it's not, a random tile, keep going while the tile is not unvisited. Hold on a second. While the random tile status is not unvisited, I don't want to set the status there. I want to random tile index. I want to say that the random tile index is equal to a static cast of util random range from 0 to m_p grid size -1. Okay, so that's what I want. So random range from 0 to that size, all right? And what did I do wrong? I think I meant to do this. So that's what I want to do. Now it's giving me some errors. It's giving me some stuff. It's saying narrowing conversion from unsigned int to float. Okay. So random int is an int, right? And this is giving me a floating point number because random range returns a static float, right? Min to max. Yeah, so what's going to happen is it's going to do it one time. It's going to find a random index, and then I'm going to check to see what that thing is. So find the random tile that I return, and I'll show you that in a second. So I'm going to say that random tile, right? Well, that's going to equal to m_p grid, and then what I want is the random tile in the index, a random tile index. So give me back is what I'm saying. Take a look at the grid and give me that tile, whatever that tile is, randomly from anywhere in the grid. Okay? So find one tile is what this is going to. So spawn an object by finding a random tile. So find an unvisited tile and set it to that's the one I want. If I find a tile and it's not empty, do it again. That's what it's going to do, Tam. So it does it once. If the tile is not unvisited, because I haven't set it to anything yet, if it's not unvisited, do it again. Keep doing it until I find an empty tile. That's what it's going to do. So keep looping. So search for an, so I want to, this should actually be here. So search for, for a random unvisited tile, and then keep looping until you find one. So keep looping until a unvisited tile is found. That's what this part does. So search for one and keep looping until you find one. Okay. There's other ways to do this, but I found that this way worked for me. If moving a tile, right, as an example, that already exists, then set its previous position to unvisited. So whatever, if I'm moving something, if I'm respawning something, again, then I'm going to say m_get tile. Take the object that I want to that I'm moving, right, and get the current grid position of whatever that object is, and I want to set the tile status to unvisited, just like we did when we moved the ship or the target. Okay, that's the first thing. Next, move the texture or the object, the game object, to the random tile, whatever the location of the random tile, right, in world space. Okay, so the way to do that would be, hey object, whatever that, I want to get transform, right, position, and I want to set it to m_get tile, whatever that random tile that I found, the random tile, and I want to find the position, whatever that grid position is of that random tile, right? I want to get the transform, and we did this before, the position of that random tile, wherever we had it, and I want to add on the offset, plus the offset. And we've done this before earlier up. So move the game object, from where it was to where the new position is. Okay, whatever the new position of the tile is. And then finally, set the grid position, right, of the object to the random tile grid position. Right, that's what we want. So we're going to say that object, whatever that object is, set grid position, because we need to do that, or else we want to keep track. Whatever the random tile is, right, we want to get the grid position. And I want to be able to do this, set grid position to some tile's grid position. And I could do X and Y here, but it'd be really great if the set grid position also took in a vec2. So if I go to definition, you can see that I only have one set. I can only set it with column and row. And what I'm asking here is to make a new navigation object method that also takes a vec2. I think this is a good use of a overloaded function. So let's do that. So again, in order for me to do that, I'm going to go to solution. I'm going to modify the navigation object by going to game objects, core navigation object.h. We can see that we have a set grid position. What we want to do is we want to say that set grid position also takes a vec2 object, glm vec2 object, which is a position. Okay, so we also want to do this. Okay, so whether it's a column and row or a vec2 object, I want to take either one or the other. we can do this by generate my implementation. And then in here, what I'm going to say is, well, m underscore grid position is just going to be equal to position, right? Because this is already a vec2 object, and I'm making this one, which is already a vec2 object, equal this one. So let's do const, so whatever that object is comes in. And now we've created an overload, two overloads. So similar to what we did before, we can take column row, or I can take a vec2 position if I already know it. This is a great little example. I didn't do this with the first class, but because I ran out of time. Going back to this, right, then I would accept this. So random tile get grid position, whatever that is, I pass that grid position into the set grid position of the object, and now they're equal, okay? And then I want to return the random tile index if I want to keep track of it. I want to keep track of the random tile index, I can do that. It's just a way of testing what that is, okay? Questions are in this one first, what I'm doing. So what I'm really doing here is I'm calculating the offset. I make a random tile pointer, set it to null pointer, right? I start off with a tile index of 0, right? So the first item in the grid, right? If you will. Find an unvisited tile, right? And then wherever I was, if this object already exists, if it's not null for some reason, right? Or if I don't have a grid position, right? If my grid position doesn't exist, right? As an example, there's got to be a way of checking this, right? For new objects. Then what I want to do is set the original position to unvisited, right? And move my object in world space to where the new object is, and then followed by that, reset its grid position and like reference the grid position to the new one. All right, that's what I want to do here. And once I've done that, I want to return out the random tile index just in case I want to know what that is. Okay, just to keep track of all that. All right, so how do we test this spawn object? Well, let's try making two utility functions in the play scene, and one of them will be a void m underscore spawn starship, and we want to make another one m underscore spawn target. So we know what those are, right? They're specific functions for the spawn object that I'm testing. So do that. Do this. And for the spawn starship, I'm just going to say m underscore spawn object and pass in m underscore p starship. So spawn the starship in a random location. Move the starship in a random location is what I'm saying. Okay? When I do this, I want to be able to do what I did before, where when I was inside of the ImGUI function, I also want to set the starship, wherever the position of the grid, I want to set that to start. So that is the only thing that's going to change. So, right? I want to say, hey, take the starship, wherever that is, and change the style status to start. Okay? And spawn this target, I'm going to do the same thing. I'm going to say m underscore spawn object, and then move the target, right? And let's get the tile for the target, and let's do, instead of me doing it, I'm just going to go back up here and grab the same thing from the tile position, because this is the starship and this is the tile. Let's just grab this and go here and put it in. And that's the only difference between one thing and the other thing. Spawn starship and spawn target, same, but I'm just specifically doing this as opposed to doing this somewhere else. Little utility functions. Not really that useful, but let's start off by spawning the starship in a random location. So going back up to the start function, and by the way, I don't need this current heuristic anymore because I don't need that at all. And I'm not going to toggle the heuristic anymore. So one thing I forgot to do is get rid of the heuristic, because that's not going to change. Let's get rid of this. I don't need this anymore. We can clean up IMGUI a little bit. But one thing is that when I make the scene, the ship right now appear in this location. Okay. So get tile is 1511. My grid position is 1511. Notice that that is the set grid position, right? And the target is going to set its position to that random position. Here, notice what I'm doing is that I have the target, right, as an example, and the target itself, by default, what happens to, where's set grid position? What is it going to be set to? Let's go to check that out. Go to definition for a second. The grid position basically sets the grid position either to a vec2 or to a column row, right? And M grid position, go to definition. You can see that I declare it here as a vec2. By default, the vec2 starts off at 0, 0. Okay, so the grid position is 0, 0 actually. Okay. So by default, even if I don't tell it where to go, it's going to set its grid position starting off at 0, 0 to unvisited. That's what it's going to do, right? The grid has to already be there. And then after it sets itself to unvisited, then it's going to position it into the new place. So theoretically, skipping back, instead of doing all of this, right? All of this part, right? Let's just comment it out. And this is what I was going to do earlier today, right? And then what I want to do is use this spawn ship or spawn target. Let's see if I can do that. So I'm going to say M underscore P or M underscore spawn target. And let's see how that works, right? Where I spawn the target position. And then I haven't added it in yet. So first I spawn it, I randomly position it, and then I add it. Let's see how this works, if it's going to break something. So, going to do some real recalculations here as we go. And random, right? Cool. Do it again, and same location. Oh man. Let's wait. Because it's going to be based on time and all that kind of stuff, and then run it again, and man, what the heck? How come? Well, remember what we're doing with IMGUI, right? IMGUI is keeping track of stuff, right? So it's going to set the position to some random number. The other thing is that this doesn't quite work for the target, but somehow if I was to do the exact same thing for the starship, let's just show you this. So let's comment it out and go M underscore spawn starship. If I did that before I added it in, how would this look? So if I randomized it and started off, I got kind of a random location, and then turn it on and find shortest path. You can see that that's okay, right? And if I reset, and if I move it around, and if I find shortest path, that's okay, right? And if I was to launch it again, then this is the same location, but this is random, right? And here it is, and find shortest path, and we're good to go. I can move it around, find shortest path, right? Let's move it way down here. Find shortest path, all good to go, right? Nice, nice. But when I start it again, then I start up here again. And when I start it again, I start up here again for the target. What's going on? Why is this the target starting over and over again, the same location, but don't think you need M underscore get tile since we're working with a tile. Okay. Could be. Are you talking about in the spawn function? So let's take a look at that spawn function and see what's going on. So, right, the spawn function, which is this one, spawn object, I get an offset, right, for the object. I need that offset. I get a tile. I get a random tile index. That's what's going to be. It's auto. I run through, right? And then it says, here's my random tile index, right? So what is it? So let's do the random tile index for the ship as an example, or the target, and let's see what that looks like. So let's print that out. So standard cout. Actually, what we'll do is it returns the random tile index. No, that's what this is. So in the we'll do it here. So in the starship, we'll do a standard cout, and we'll say random tile index. Actually, we'll say just a random tile, which is better, is equal to, open up this, and we'll say that that is the get grid location. So m_p starship, and then get grid position dot x. And then m_p starship, get grid position dot y. Right? Same thing we've kind of done before. Random, and this is the random tile for the starship. So starship spawn position. So starship spawn position. That's what that is. And then we'll do the same thing for the target. So instead of starship, we'll do this. And let's see what it is, right? This will tell us the exact position of where it is every single time we respawn. Let's do it. So run. So it looks like our random location for our starship, right? Oh. Okay. So let's do it. So the random location for the target is 12.4, right? There's 12.4. And the random location for the position for the other object is 16.1. You can see that they match these. Okay, so 16.1 and 12.4. Okay, let's move them around. And find shortest path. Okay, 10. Move them around, find shortest path, and 14. Right, finds it. Nice, nice, excellente. And when we run it again, 13.4 and 2.3. When we run it again, 11.7 and 14.4. Run it again, 18.1 and 14.4. Look at that, 14.4. And 14.4 again. Find shortest path, right? 0.4. And run it again, 14.4. Why are we always getting 14.4? But meanwhile, the ship is randomly being spawned. Why? So Tam says, random is seeded by time, but is not Unix timestamp in MS. Microsoft? I don't know. Because, well, why is the ship working but not the target? Shipper's working great. Target, not working great. Okay. So that is something that we have to configure, right? We're getting a random thing, the random number here. But when we're moving the target around, it's like it snaps to the same spot multiple times. So let's run it again. Okay, so now it's 16.4, and Tam, maybe you're right, but why the target and not the starship? Look at 5.6. So 5.6, and then 6.5, right? So the starship is doing perfectly what it's supposed to do, but not this. Not this, right? I mean, again, it's not a big deal, but why is the question. All right, so we're going to come back to that because I don't know why. It shouldn't be doing that. It should be the exact same thing, right, when it comes to the target, right? So I pass in a reference to the target to spawn. So again, if we trace it, here's the target, right? The offset is okay, right? The random tile is null pointer. The random tile index is 0, so we reset this. Just to be clear, let's make this an int. Who cares, right? And then what about this grid size stuff? Is there such an error from random range from 0 to 1 that somehow my grid, but then it would error out for both, right? It would error out for both. So that's something that's weird. Could it be that there's something else that's happening here where I'm accessing or keeping track of the tile, somewhere up here inside of IMGUI, and it's a bit of a mess? Don't know, right? But somewhere it could be the statics that I'm using for goal position and start position. It could be that, right? Because it's trying to read what the grid position is from those numbers. Maybe there's some kind of error. Again, it's kind of a needle in a haystack at this point, but we would have to trace it with a bit of code. For now, not that important, but it does work. Like this random function for spawn target and spawn starship totally works even before we add the starship and the objects in there. All right, I want to add some, so we've kind of done this, kind of, without overlap. It doesn't overlap so far that we found, okay? Here's the stretch goal, and we have some time to do this. I want to generate random obstacles and then test pathfinding, okay? So, yeah. So this is a little bit more involved. What I want to do here is I want to make a brand new object called a mine object, okay? So going back to this, we have some objects. And by the way, let's put this up on GitHub because we made some changes. So added spawn object method. So what I want to do is in my game objects, I want to add a new game object called mine. So it's going to be called, again, it's going to be a .h. I'm going to browse to the src folder, and the first one is going to be called mine.h, right? And I want to add in the .cpp, which is mine.cpp. And mine.cpp is going to include mine.h, like normal. So we're doing a new object here, and we already have examples of this object, objects like this before. It's not like this is a new thing, right? So just like we did before, we're going to say if not defined mine, then define it. This is our stretch goal, so we'll see what happens. I'm going to create a new class called mine that is going to extend a public navigation object. Okay. A classic, the static navigation object. Okay, and what I want to do for the mine itself is I want to also do an end if. How about that? I don't know why I did this that time, but there we go. Standard stuff, right? I want to define a mine in the public area. I want to define a mine constructor and a mine destructor, right? So, okay. And of course, I want to generate missing members. Right? And these are not just inherited, but they're the life cycle objects, life cycle functions. Again, I mean, it's just this. That's all I really need so far. Okay, so one thing at a time. Now I want to generate definitions by declarations. I want to make my mind destructor equals to defaults, like we've done in the past, and I want to kind of define my draw, update, and clean functions a little bit, right? So really, all we need is an object, right? So I'm going to say let's take a look at other objects that are out there that'll help us. Starship is an example of that. So Starship, I want to pull this in, and I'm going to pull this to the right of this object here because it looks like we may need util and iostream and game.h. But let's start off with texture manager. So that I'll definitely need. Maybe I'll need util.h, don't know. Maybe not. But some stuff we do need is in the constructor function, this load function and these three lines here, maybe all the way to here, as an example, I probably need. Okay, so, and instead of loading in the NCL, there is in textures there is a mine.png. We'll call it mine. Okay. Velocity was 0, acceleration was 0. Is colliding is false. I don't need rigid body stuff pretty much at all, except for collision. They'll kind of start off as what they are. It's definitely going to be, is it going to be an agent? I mean, I could make it an agent for now. Maybe I will. Or I just could make it another type of object like a mine. Again, I'm not sure what I'm going to do here, but if I wanted to, and if I wanted to make it a mine like this, then I could go to definition, and just like I have target, player, blah, blah, whatever, because even though it's a navigation object, it's going to be a mine. And let's make it under before the start button, I'll add mine in there. Change this to mine. And we're also going to draw it, right? I think this is important. We don't need any of this stuff. But the drawing function definitely for get transform position. I mean, yes, we could do it this way, and let's grab this. We don't care about the current heading. That's always going to be 0. And it's not going to draw a starship, but rather mine. And the transform position is where we want to draw it. So that's where X and Y is. Okay. Theoretically, what we want, if I go to the draw function, go to definition, it would be nice if we had a draw function that also took in a position, right? But I'm not going to overload that function now. But it's screaming for one because I'm doing this over and over again. All right, cool. So that is the draw function. So it'll draw the mine when I make it. Update and clean remain empty for us because we're really not going to do anything there that's has anything to do with anything. Like it's literally just putting a block in there. Okay, that's what it's going to do. So that's the mine. Okay, so I have a mine object now, and we don't need this anymore. And we have a mine, right? Okay, only thing I use Texture Manager for is this. There's nothing else that I need, right? Everything else is the same. Let's add this to GitHub. So again, if I run this code, it shouldn't crash because nothing's happening. We haven't done anything extra, right? And what I want to do now is I want to generate random mines all over the place, okay? After I place my ship and my my target, I want to place random mines everywhere else, okay? So that's kind of what I want to do. So added mine game object or navigation object, right? Now, why did I make a navigation object? Because it's going to have a get grid position, set grid position, right? That kind of stuff, which is important to start off with. Okay, so that's the mine. And what I want to do now is I want to randomly place the mines on the grid, okay? So there's a couple ways to do this, right? I want to keep track of mines, all the mines. I want to be able to keep track of them. And the reason for this is because if I keep track of them, then I can erase them, then I can hide them by looping through them all. Let's say I don't want to show the mines or whatever. I can do that. So inside of the placing.h, if that's what I want, just like I have my game objects, which are target and starship, I can add mines. So what are mines then, right? Well, mines is a vector of mine objects, right? So let's add a couple of additional things for game objects. So one, let's add some mines. And for the mines, I want to say that m_mine num. We're going to say that the mine num we're going to set up is in the config file called mine num. I already have that for you where you can set the mine number by default. I want to set a standard vector of mine pointers called m_mines. And they should be m_p mines because they're pointed to mines. Okay. I want to make a few mine functions, if you will. Okay. One of them is going to be void m_build mines. I want to make another one, which is m_erase mines. I want to erase them, build them. And then I want to make another one, m_spawn mines. Okay, so those three functions. Let's do them. So generate implementation. Generate implementation. One more. And like that. Okay, so now that I have these build mines and erase mines, again, we'll see if we need them all, but I'm just thinking, okay? So build mines, I'm gonna do a for each loop. And I want to say let's go back. I want to do a for I loop where I want to start off with an index of mines. And it's going to be where the index is less than m underscore mine num, this one. And I'm going to say auto mine is equal to new mine. So I'm going to set up a new mine, and we're going to add child the mine that we kind of create, where m underscore mines push back the mine, whatever that is, right? And I want to then make the mine equal to null pointer so we don't have a memory leak. Okay, it's temporary mine, put it together and push it back. So that kind of builds all the mine pointers, right? It also added them all. Where would it add it? To the top left corner of the screen. Okay, so it does add it somewhere. That's the first point. The second point is, what about when I want to remove them? So I want to say for each. This is where I do the for each. For each m underscore p mines. Man, I always do that. For every mine in mines, then I want to delete the mine. Again, not the most elegant thing. And I want to set the mine to null pointer, right? Just to be sure, I want to say m underscore p mines. Let's clear it, right? And then m underscore mines dot resize to 0, and then m underscore p mines. I'm like overkill here. Shrink to fit. Yeah, that's what I want. Which is going to basically just collapse that whole vector, all right, right down to nothing. So why do I want to do this? Because it's going to hold information, and I want to just get rid of them all. One thing that we've done is we added mines to the scene, and yet we haven't removed the mine from the scene. So I want to remove child that particular mine, and let's see if that's possible. So I want to do remove child the mine that I want to remove. Okay, so that's kind of looks through the list, takes that thing, remove it, so it's no longer displaying, right? And then it erases it, and I can put it back. Okay, that's how it works. Oof. Finally, spawn mines. How does that work? So one thing I want to do is when we spawn mines, I want to do the same thing we did before. I want to spawn an object for each of the mines that I have in mines. So when I do it, I want to do something like this. I want to say for I index. And when I look at the m where it's less than mine num, I hate that. Sorry, my Visual Studio was made differently before, so I could just like tab. Anyways, where less than mine num, then m underscore spawn object m underscore mine num mines p mines index. So I want to say that grab that mine as an example and spawn it in a random location. That's what it's going to do. Okay, and then so I want to take that index and I want to get the tile from wherever that is, and I want to set the tile state, right? So I've spawned a random object. It's got a tile location, right? And I want to set that tile state, whatever that tile that the mine is sitting on, right? That object, right? The tile that is, so get grid position, I want to m underscore get tile mine's grid position, and I want to set the tile status of that mine to impassable. Impassable, okay? So that's going to place it as an I, okay, like we did before. Okay, and that's what spawn mines will do. So build mines will completely, make mines. It'll add the mine to the scene, and then spawn mines will randomly place them in different positions. Okay, so what we want to do is, for when we actually do the start scene, then when we do the start function, where would the mines be started? We have to think about this now, because we want to make sure that it doesn't clash with something that already exists, right? So here's something to think about before we continue. I'm going to call the start function. The start function is going to build the grid. It's going to, remap all the tiles and all that stuff. It's going to spawn a random target. It's going to spawn a random starship somewhere. We want to then build the mines, okay, and then finally spawn the mines in a random location. Okay, that's what we want to do. So let's see if this can work. So again, to give you some ideas, start. So we've done all this. We compute the tile cost of where everything is, and then what we want to do is we want to m_, build mines. So here's where we build mines, right? And then m_, spawn mines. Okay. Remember what this does. Spawn mines randomly spawns a mine number. And just to find that before we end for the day, if we go to our core config.h, then so far the mine number is 50. Let's reduce that to 10, something that's reasonable. So I change it here, not 50, right? And then we can modify that later, right? When we increase the mine number and so on. So let's see if this actually works. So run. And let's see if it's going to do what it's supposed to do, or just going to crap out, right? Because that can happen. We haven't tested any of this function out. We have erase mines. If I want to move them around again, if I want to respawn them, right? I want to remove them and put them back. This is pretty cool, right? So it gave me like these random mine locations, and they're not overlapping. Guys, this is the beautiful thing, right? So here's my toggle grid, right? And if I stop it and do it again, this should be in different locations, right? So it kind of creates some obstacles. And I think this is what I wanted to do. And this is the last thing we'll do. So now that we have obstacles, and by no means is this the last possibility for this, but I want you to think about what's next. So how do I do pathfinding? How do I test the pathfinding next? And I'm going to go down to this piece where we do the find shortest path. And let's review some of this. So what if now we don't care if the tile is, we don't care if the tile itself, right, like way up here, if it's a null pointer. If it's a null pointer, well, that's an issue, right? That means we're looking outside. But what if the tile itself is not a null pointer, but an impassable tile? So if it's null pointer or if it's an impassable tile, one or the other, we don't want to push it back. So if it's not equal to null pointer, and if m_p open list 0, neighbor tile, right? And then what we want to do is the get neighbor tile index static cast neighbor tile, right? Index. If this thing right, that we're looking at, if the neighbor tile get tile status, right, is not equal to, and we're looking for a tile status specifically of impassable, both those conditions have to be met in order for us to avoid it. So the neighbor tile, whatever the neighbor tile index is, 0, 1, 2, 3, as long as the tile is not impassable, then we're okay, is what we're saying. Don't do it if it's one or the other thing. Okay, so I need to know that it's not null pointer and that it's not impassable to add it into the tile index. So I want to basically ignore it. Okay, I don't care about the tile cost if it's impassable or if it's a null pointer. If it's one of those two things, just ignore it. Don't even put it on the neighbor list. Okay, let's see if that works. So again, it may not, right? We haven't tested this out. So let's look and see. So we have this find shortest path thing, and I'm not moving anything yet because that can cause a problem too. Find shortest path. And notice it says it goes like this. It goes choo, 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 and then it goes here, and then it ignores everything, and then it goes right here. Look how I did that, right? Okay, let's do it again. So we jig it, as an example, and it's here. And let's do this. Let's go to config, and let's put them back to 50 mines. Okay, let's see how that looks. And we run it. Again, there's still problems. Okay, I'm not telling you there's not problems. There's still issues, right? But the idea here is we can randomly generate a map, right? And when we do so, you'll see that now there's 50 tiles. Here we go. So there's 50 tiles. Is there a path? Number one, that's the first thing, right? And so find shortest path. And there is, right? It shows you the shortest path. It goes to them, right? It goes here, 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 and it kind of goes around there. Right? Pretty cool, right? Went around the tiles, and then it found a shortest path there. Let's try it again. I'm not moving anything yet because that's going to cause issues, right? And then, okay, that's definitely going to be some issues, right? We're going to have to go around here. Let's find the shortest path now. And you can see that it went around this way and there. So it found the shortest path this way. It's dying for an I'm GUI. That's too easy. Let's do it again. Okay, that's good. That's a good one. And again, we can see that that's pretty good. What the heck is it going to do here? There's like some real issues here. All right. Find shortest path. Okay, cool. So look at that. Going here, went up, went across, went up this way, and cool. Right? That's pretty good, guys. That's really good for what it can do. Now, what if, here, let's break it. What if I move this stuff around? Well, that shouldn't be allowed, right? Shouldn't be allowed at all. I mean, sure, I can recalculate, but what if I wanted to stop here? Yeah, that should not be allowed to be done, right? I shouldn't be allowed to do this, and I definitely should not be allowed to do this. Shouldn't be allowed to do that, right? Because it's a mine. So what I need to do then is when I move, last thing, guys, I know we're running a little bit late, but bear with me because this can be cool, right? If we do it right. When we move stuff, either one, okay? When we move either one, and this is inside of the IMGUI function, right? That's the way we want the, so these are the GUI, this is the GUI function. In the GUI function, when I move stuff here or here, not only do I want to reset the grid, but I also want to reset the objects in the grid. I want to respawn the objects in the grid again, okay? And that means the mines. So M underscore, this is where it gets difficult, spawn mines, okay? So if I move this, or if I move this, I want to respawn the mines to wherever I want. And it's going to be after I compute the tau costs. There, okay? Do you understand? So that way, if I did this, and if I move this thing, it'll be moved, and then it won't be overlapping. Let's check that and see if that works, or if I just messed up, right? So here's the mines, but I want to do one of these, and then as soon as I move this closer, you can see that I have a different scenario every single time. Let's find the shortest path. And you can see that it did that, right? So here, and it went down there. And we can find the shortest path right through the minefield, which is pretty cool, right? Let's do it again. So remember when we move any of this stuff, right? I can move it up and anywhere I like. There it is. So that's kind of really tricky, right? And find shortest path. And there it is again, right? Doesn't get messed up. What about though, if I have a lot more mines than this? So let's make it from 50, that's pretty good, to 200. What about then? What happens then with those kind of things? Is it possible that we can run into trouble? And yeah, the answer is yeah. We should be able to do this mine number as an example. We start off with the mine number, but we should have some kind of slider control on IMGUI that allows us to randomly kind of generate the mines. Okay, this is impossible, right? Look, my ship is here, and my target is here. There is no path. This is going to error out now when I do it, right? Watch. So if I do find shortest path, then it's just going to keep going forever. There's no way to stop it, right? And if you notice, guys, the amount of memory is going to continue to grow and slowly grow and slowly grow over here until it is an endless loop, because there isn't a path. How about 100? Okay, even that is going to be challenging. And I want to bring this up because we haven't dealt with that yet. We haven't tested it. This is the testing scenario where I want to create obstacles that are random on the map, right? And present a case for you to say, I'm not going to find a path afterwards, right? Here, this is a very difficult one to do too. I'm here and I only have one way up. This could be really challenging for me to figure this out. Let's see if it works. If it's going to find the path all the way here, find shortest path. And again, it's got issues. Why? Because it's looking for anything that's going to happen. We find this one, right? Take a look at the code here, right? And in the code, it gets stuck, right? I'm here and it can't go back. We don't have a way, we don't have a means of it going back and going to here. We just don't have that ability, okay? So that is an issue. That's a huge issue, right? And I'm mentioning this because with this many mines, this many obstacles, it's showing our weakness, right? One more time. Another example. There's no path, right? Let's do it again, but this time I'll move things around. So even if there's no path, I'll make a path, okay? Is there a path? There is looking like a path through here. It's pretty convoluted. We can probably do it. Let's do it and see what happens. Boom. Even then, we can't find a path, right? Why? Well, it all comes down to how everything is positioned. It's going to continue to climb again. Why? Because look what I want to do. I want to go from here to here, and then from here to here. And then we can also take a look. We can also inspect what this thing looks like, right? It's trying to output the path, but it can't output the path because path length is just too long, and it's trying to do something with the ship that it can't possibly do, right? So that's why 50 mines is what was chosen as a demo. But what it does is it speaks to the weakness we have for our pathfinding algorithm right now. Remember, we can only find one type of path. As soon as we mark it in the open list, can't go back. There's no way back, right? And this is what you guys need to figure out. There's got to be a way of when I have them. Well, this is dumb. When I have a a thing like this, let's move this here. Oh, so that was wrong too. That spawned inside of each other. That shouldn't be allowed, right? Is there a path? And with this kind of scenario here, right, where there's a number here and there's a number here and here, may not find even here the shortest path. Let's see what it does. So here it did, right? and it went around it and it doesn't go through it, which is good. It ignores the impassable tiles. That's what it does, right? And let's see if we do it again. Let's see if I move this kind of up to the top or in the bottom. So really far away. Okay, so now again, you can see that these two tiles are good, but look at this trap that we have in here, right? If it went here or even here, this is going to be challenging, right? Because it might not find a path. Let's see. Yeah, see, look at that. Didn't find a path. So why didn't it? Well, because we're limited in the moves we can do, right? It can't go back. It can't backtrack. It can get lost. It can get trapped in the stuff that it does, right? One more time. And I'll explain this to you one more time, and then we'll stop for the day. So things that need to be changed is what we're saying. Is there a path? Right? Yes, there is. There's a path. And here it is. Look at that first path, right? Because it went from one side to the other, right? But if I move it around again, right? So let's move it around over here. Is there a path? There should be. Goes around this way and down. Find shortest path. No problem, right? It found the shortest path. Okay. I'm going to ask the question again. Is there a path? Maybe. We have a clear area here. This isn't so clear. And once we have this scenario here like this, 2, 2, and 2, and it's in a corner like this, may not find it, you know, depending on the path finding algorithm. Look at that, right? So it kind of works, but there's some issues. And we need more work on this thing. So again, Tab says, it's going to a dead end and doesn't retrace its steps, in which case it should probably check line of sight or cost over time. Exactly. These are the things that it needs to do, and we haven't had a chance to do it. It's, like I said, this algorithm that I'm giving you is neat, but incomplete. Okay, for the lab, whether you got the random tile spawns or not, for people that are watching, as long as you can generate, you know, you can do the pathfinding piece and move it around and do the shortest path, whether it's like through the minefield or not, right? If it shows the path like this and it's pretty accurate, you're good to go for today, okay? I need a couple of examples, maybe a few screenshots in different positions. Obviously, it would be nice. But if you're going to use the mines, this is pretty cool. Sometimes, though, you may not find a path, and that's okay, right? You may not find a path because this is a random map that we're creating. Think about these as walls. Random set of walls, not mines in space, okay? All right. So that's it for today. Ethan's got a quick question. Can we have groups of 3 for assignments? Which assignment? Assignment 2? The answer is no. For assignment 2, there's only groups of 2. Yeah. Assignment 2 is groups of 2 or a group of 1. All right, so that is this. Let's put this up on GitHub. So those are the changes. So we'll say added random mines, right? So commit all, and then push. Lots of optimizations. I can sit down here for another couple hours and optimize just the random mine spawning thing. But what we've done for today is we've kind of done our stretch goal, which we have here. We've kind of done this. We do activate it. We do reset the grid every time, and we may not have a viable path. These are all things we've done. Do we need more work here? Absolutely. This is not done for today. If we wanted to continue, I could continue working on this thing for the next hours. Okay, guys, that's it for me today. Good luck on your assignment. Again, it's due on Sunday at midnight. Good luck. And I will talk to you guys next week for your midterm test. I will release the midterm test just as a final note again on the Monday, right? And you'll have until the Friday to complete it. Okay, good luck, guys, and I'll see you guys next week. Tam, go ahead. Let me just stop producing this, and then I'll take your question. Okay, go ahead, Tam.